So let's see the dissociation of these. So sodium nitrate would be NaNO3, giving you Na plus and NO3 minus. This is already balanced. Let's try magnesium sulfide. Magnesium sulfide is Mg, sulfide is S, valency 2 and 2. This will cross out, so MgS. Here you have the dissociation. And calcium phosphate, CaPO4, valency 2, valency 3, cross multiply. So Ca3PO4 twice. This will split, will give you Ca2 plus because the valency of calcium is 2. PO4 will give you PO4 3 minus because the valency of phosphate is 3 and you'll have to balance it now. So you have 3 calcium and 2 phosphate. And the charges balance out. Iron-free sulfate, you will have iron and sulfate, valency 3, valency 2. So Fe2SO4 3 times. And you have Fe3 plus because the valency of iron is 3. And SO4 2 minus. And you balance the equation 2 and 3. Here you have the dissociation. For the naming, this is sodium hydroxide, copper 1 sulfate. It's 1 because it's Cu2SO4. So SO4 gets 1 and Cu will get 2. So after the cross multiplication. So calcium nitrate and ammonium sulfide. It's just as here, so it's sulfide. This one was already done as an example. Now let's see the dot and cross diagrams for ionic compounds. Whenever you're doing dot and cross, we are showing only outermost electrons now. So let's do for sodium chloride. We will not be using this table for now. So sodium chloride has formula NaCl. It's very important that you get the formula right, else the dot and cross diagram will be wrong. So make sure that you do the cross multiplication to get the formula. Now, from that formula, I will look up for sodium in the periodic table. And I know that sodium is going to want to have a completely filled outermost shell. So in its outermost shell, sodium actually has 1 electron that is going to be lost. So if you look at the electronic configuration of sodium, here, this 1 electron will be lost, so that in the outermost shell, you will have 80 electrons. So sodium is going to have 8 electrons. We're not using circles anymore to show dot and cross diagrams. Remember in IGCSE we used to use circles. We're not using circles anymore. We're just showing the electrons all around the atom. So it has lost 1 electron, so it will be Na plus, like that. And chlorine, because it is in group 7, it will already have 7 electrons, but it will gain 1 electron from the sodium. So chlorine, Cl, already has 7 electrons. So I will draw the 7 electron of chlorine. And chlorine is going to gain 1 electron from sodium. So it gets that 1 cross. And we'll have charge minus. So here I have the dot and cross diagram for sodium chloride. Let's do another one for magnesium oxide. So I'll get the formula right first. So magnesium oxide, valency 2, valency 2. So formula is MgO. Now magnesium is a metal. It is in group 2, which means that it will lose 2 electrons. And definitely magnesium is going to have 8 electrons. It's in its outermost shell now because it has lost 2 electrons. So if you want, you can write the electronic configuration, but eventually most metals, except lithium, which is going to have 2 electrons, all other metals will have 8 electrons in the outermost shell when they are stable. So these 2 electrons will be lost, and then you see you have 8 electrons. So I'm going to draw my magnesium with 8 electrons in its outermost shell like this, and it will have charge 2 plus here. And now oxygen is in group 16. So group 6, actually it will have 6 outermost electrons. So 1, 2, 3, 4, 5, 6, and then it will gain 2 electrons from the magnesium. So it will be O2 minus. So here you have the dot and the cross. Make sure that you respect the electrons chosen. Let's do for aluminium fluoride now. So aluminium fluoride, again, let's do the cross multiplication, valency 3, valency 1. So I will have AlF3. Now aluminium will have 8 electrons in its outermost shell. So I'm going to have Al with 8 electrons. But because it is in group 13, so group 3, it will lose 3 electrons. So Al 3 plus. So the charge is depending only on the valency of that element. And outermost electrons definitely will be 8 because these are the electrons in the inner shell. And fluorine is in group 17, so group 7. So it will have 7 electrons. And then it will gain 1 electron from aluminium. So I have F minus. But you see the charges are not balancing out. But then if you look at the formula, it's AlF3. So you need to have 3 fluorine in that. So here you have the structure or the structure diagram for aluminium fluoride. Let's try barium iodide now. So first thing, again, I'm going to write the formula. BAI, barium is in group 2. So valency 2, iodine is in group 17 or 7, has valency 1. You can cross multiply BAI 2. Now, barium is definitely going to have 8 electrons in the outermost shell. So I'm just going to draw barium with its 8 electrons. So as you can see with this method, you can draw the ionic dot and cross diagram for any ionic compound. So Ba2 plus, and iodine is going to have 7 outermost electrons of its own. And because it has valency 1, it will gain 1 electron, so 1 cross. Therefore, it's I minus. But when you look at the formula, because there's 2 here, I'm going to put a 2 in front of the iodine. So here I have the structure of the dot and cross diagram for barium iodide. Now, always respect the fact that the metal is put first, so you will draw the metal first, and then the non-metal is put second, you will draw the non-metal second. Do not draw something like I minus and Ba2 plus like this. This is wrong. Okay, so you're going to try out a few ionic dot and cross diagrams.